Okay, here we go. 4 isotopes of lead, including lead 204, 206, 207, and 208. Why are these isotopes of each other? What makes them isotopes, Joe? Say what? What about the atomic number? The same atomic number, and they have different mass numbers. This one's a mass of 204, 206, 207, and 208. Let's get rid of that. I don't know why this is so far away from me. Okay. Which isotope? Oh, the average atomic mass. The average atomic mass. And the average is based off of the abundances of the atoms that we have. No, we do not want to do that. Which isotope is most likely, which isotope of lead is likely to be the most abundant? Megan. Lead 207. Can you tell me why? I love it. It's a perfect answer. Because the average is closest to 207. So therefore, that is the most abundant isotope. Okay. What do all isotopes have in common? Olivia, do you know what they all have in common? I'll give you a hint. I'll start it. Same number of... Good. They have the same number of protons. Another way of saying that they have the same number of protons, Jasper, is to say they have the same atomic number. I love it. Okay. Okay, we've talked about that for a couple days now. Moving on from it, so hopefully you have that in your brains. Okay, explain why carbon-14 and nitrogen-14 are not isotopes. Lily, nice and loud, like you hate me. Yell at me. I love it. Okay, they are different elements. Carbon has an atomic number of 6, and nitrogen has an atomic number of 7. They have the same mass numbers here, but that doesn't make them isotopes. The same number of protons makes them isotopes. Good. Write the atomic symbol, the symbol notation, that's this that I just wrote up here, for the 2 isotopes of uranium whose atomic number is 92. First and foremost, what's the symbol for uranium? U. It's like what you say to somebody you don't like. Hey, you! Alright, what number goes in the bottom left, Walters? 92. Good job. Okay, so we've got 2 isotopes. Both of them are going to have atomic number 92. Let's put the mass numbers on there. The mass number is going to go up here, Aiden, right? Okay. This first one says, whose atomic number is 92? One isotope has 142 neutrons. What number is going to go there? Somebody said it. Why 234? You guys have to get angrier with me and yell. You add the protons and the neutrons. Okay, so 92 and 142 is 234. 234. Be careful. They gave us neutrons here. They did not give us mass number. This one says the other isotope, that's this guy over here, has 146 neutrons, which is 4 more than this guy had. So therefore, this has to be 238. All right, good. GTG, good to go? Okay. Now, on these questions, they didn't give us an atomic mass. They gave us a mass number, so we'll just use the mass numbers to do it. When you are doing average isotopic mass, you're going to take the percentage and you're going to multiply it by its atomic mass. In this case, we're going to use mass number because that's what they gave us. Okay? Remember to take your percent and change it to a decimal by moving the decimal 2 places to the left. All right. And this is the most important part, writing it out. The actual answer is not the important part. Okay. 6% becomes 0.06. What are we multiplying that by? Changing colors. What are we going to multiply it by? 54. Okay. Plus 92%, which becomes 0.92, times 56, plus 2%, which becomes 0.02. I love it. And we've got it multiplied by 57. That is probably going to be your answer on a Regents exam. It's not going to be what's the actual answer. Okay, and the reason for that is because they want to know you can do the numerical setup. So don't take shortcuts and do it all in your calculators. Now, without doing any math, do not put anything in your calculator. Tell me what the mass is going to be closest to. Ooh, Nick. 56. So I'll just put it's going to be approximately 56. And now let's do the actual math and get a number. I don't think I did this. So let's take a calculator out. Let's do, clear the calculator. 0.06 times 54 plus 0.92 times 56 plus 0.02 0.02 times what? 54? 57 times 57. 55.9? Is that right? Guys, you have to get used to checking my math. I make mistakes. Okay, so the average mass is going to be 55.9. Is it about 56, which is what we told or we thought it was going to be? That's a good way to check that I did it right. Okay? All right, let's just write these out so we have them. 0.95 times 14 plus 0.03 times 15 plus 0.02 times 16. My answer should be approximately 14. Somebody give me an actual number. 0.95 times 14. 14 point what? 07? Okay. Looks good to me. These aren't hard, right? Guys, I can't hear her.
How do you know what number it should approximately be?
Good question. You see how this 95 is the biggest percentage? Whatever the biggest percentage is, it's going to be closest to that number. Atomic mass units, AMU. Okay, the unit for this would be 14.07 atomic mass units, or 14.07, and the shorthand is that funky looking U shape. Okay, so any one of those would work. Alright, so Lily, look up here. 80 of 127, 17 of 126, and 3 of 128. My answer should be close to 127. Let's see if it comes out that way. So I'm going to do 0.8 times 127. Oh, my pen just died. Plus 0.17 times 126 plus 0.03 times 128. 0.8 times 127 plus 0.17 times 126 plus 0.03 times 128 equals 126.86. And see how it came close to 127? That's a way to double check your answer. Okay? Any questions on this stuff? Alright. I want you to do number 10 down at the bottom. The reason I'm picking number 10 is because they got some ugly numbers down here, and I just want to make sure you understand. These are the actual atomic mass units. So I'm going to take a picture of it. I just moved it to another page so that you can see. Back on. Okay. 0.0435 times 49.99461. Yes, you have to write the whole thing out. Plus 0.8379 times 51.9405. Plus 0.095 times 52.9407 plus 0.0236, I ran out of room, times 53.9389. I just squeezed it on there. Okay, that's the correct numerical setup. Whether they give it to you in a chart or they give it to you in a word problem, that's what they're talking about when they say correct numerical setup. And if they ask you for the actual number, what did you get? You got 51 point what? 929? That? Anybody else get this number? Yes? Oh, uh-oh, that's not what I got. All right, let me just double check the math. 0.0435 times 499461 plus 0.8379 times 50. Oh, there's my problem. I put 54.9. Aha! See, I told you I make mistakes. All right, and then 0.02 times 53. Yeah, I typed in the calculator wrong. Okay. 51.99. Looks like a good answer to me. Good job. Did you get that? You guys got that number? Okay. Alrighty. Any questions on isotopes? If they ask you to find the average isotopic mass, but they don't give it to you like this, can you find the percentages? Do you remember how to do that? Let's just do one because it's going to be on your lab. Let's say here is your sample. Okay, in your sample you have 6 isotopes that are those blue X's, 3 that are these green circles, and I'll do orange, and 1 orange square. It's a very perfect square. Okay, if the X's weigh 12 atomic mass units and the circles weigh 14 atomic mass units and the square weighs 15 atomic mass units, okay, can you find the average isotopic mass? Yes, how would you do it? Yep. Okay. Keep going. No, don't talk anymore. Shayla's going to be your voice because you've got no voice, right? All right, Shayla, what would you do? Add what together? Well, let's go ahead. Find the percent of each. Now, I made it easy for us, right? Can you see that I made it easy for us, math-wise? I have 6 of these X's. So if I'm doing the X's, I have 6 out of 10, there's 10 total in here, are going to be, times 100, is going to be 60% X. And then my green ones are going to be 3 divided by 10 times 100, which is going to be 30% of these green circles, and 1 out of the 10 times 100 is going to be 10% are these orange squares. Okay, now that I know that, all I have to do is take this percent multiplied by its mass, just like we did before, and we can find the average mass of what's going on in here, no matter what the size is. Okay, so we're going to take 0.6 times 12 plus, what? You?
No, he was sleeping. Because you're so boring and stuff.
I know, it's okay. I can live with that. 0.3 times 14 and 0.10 or 10% times 15. And then we just do the math, and hopefully my average comes out close to 12. So remember, I made these numbers up. $12.9? Okay. I like it. Alright, isotopes are done. Does everybody know what an isotope is? We're moving on. Let me just stop the videotape.